Hello, hey everyone, good evening. Am I audible? Just let me know, and sorry for quite delay. Please quickly tell me that am I audible or not, so that we can start the session. Okay, okay. Hi Abhishekta. Okay, okay. So let's start the session. Okay, so I will and welcome to our new session. And here, what we will do, we will just visualize and try to remember whatever we have read in our books, and we try to think the probable predictable question. Okay, so I will just show the figure, and you try to think what type of question can be formed. Then I will show the question, and then you will answer. Okay, so let's move. So quickly just observe this figure very carefully. This is the figure of a virus. I hope you can understand that this is the figure of a virus. So here everything is present, like this is the spike. Okay, this is the spike, and this is the nucleocapsid, and this is the genetic material. So can you please, okay, have you seen this figure? Now let's jump into the question. Okay, so my first question to you guys, that the basic structure of the virus can't be. Okay, so here I have given the basic structure of a virus, and you have to tell me that this structure is not possible for which virus. Okay, so SARS-CoV-2, one, second is influenza, third is polio, and fourth is adeno. Okay, so quickly tell me that which basic structure of virus is not possible. Quick guys, quick, first up. Okay, quickly tell me that the basic structure of virus can't be. Okay, so I'm helping you. So the answer is adenovirus. Why adenovirus? Because all these three are enveloped virus. Okay, all these three are enveloped virus. So remember that adenovirus has no envelope. Okay, that's why it's different from the rest three virus. Okay, so let's another question for you guys, that virus. Okay, the question is that virus may get their envelope from cell plasma membrane, ER membrane of host, Golgi membrane of host, and virus synthesize its own membrane. Okay, so we all know about the virus basic things. Okay, that how virus replicate. I think you have read this. Okay, just try to think. Virus may get their envelope. Actually, I want to mean that this is the envelope. I hope you know that this is the nucleocapsid, and this is the envelope. Okay, this is the envelope. So can you please quickly tell me that virus may get their envelope from which kind of things from the host cell? Is it possible for you? So the answer will be, can you please tell me? Okay, so the answer may be, it is MSQ ABC. Virus may get envelope from plasma membrane, or from ER membrane of the host, or Golgi membrane of the host. Okay, so guys, can you please quickly tell me that whether my voice is visible or not? Sorry, my voice is audible or not, and the screen is visible or not, because I'm not saying any response. So at least response, guys, please. It's very important to communicate. Okay, and if you want, then I will explain very slowly, don't worry. Now this is the figure of a particular enzyme. I hope you all have learned DNA polymerase. Okay, DNA polymerase and replication. So this is the part of the things. Okay, so this is the structure, Okay, and from here you have to just look it very carefully, then I will give you some question. So we know that it is DNA polymerase 3 and it's present in prokaryote. Okay, so this is the basic structure, and this is theta, this is epsilon, this is alpha, beta, tau, gamma, okay, delta, psi, chi. Okay, is it buffering? Sucks, is it buffering? uh, is it buffering? I think no, no. It's, please guys quickly tell me so that I have to check that is everything okay or not. Is everything okay? Hey Neha, like please quickly tell me that it's okay or not. Okay, so my question to you guys, that which subunit is directly associated with the processivity of DNA polymerase? Okay, okay, Dipshika, just do it. Okay, which subunit is directly associated with the processivity of DNA polymerase? Alpha, beta, tau, and epsilon. Okay, quickly do it. Quickly. Okay, which subunit is directly associated with the processivity of DNA polymerase? We know that every subunit has different function. So can you please quickly tell me that which subunit is important for processivity? I hope you know that alpha is responsible for something, beta is responsible for something. Okay, so this guy is saying B. Yeah, it's B. B is beta subunit is responsible for the processivity because it is the beta clamp. Okay, it is the beta clamp. And what alpha do, guys? Alpha is just say polymerization. Okay, it's polymerase. Okay, no, it's beta. Okay, and epsilon do the proofreading. Okay, and tau, they just dimerize the protein like DNA polymerase 3. Okay, and help the DNA polymerase 3 to move through the double strand. Okay, okay, guys, let's jump into another question. So how many bonds may you get through SDS page of SDS page electrophoresis? Suppose uh, I'm telling you to perform SDS page, okay, of this particular enzyme DNA polymerase 3. So the figure is here. Now quickly tell me that how many band you may get through SDS page electrophoresis. Okay, quick guys, it's a really easy question. Don't think too much, you have to solve it. Okay, quick guys, quick, hurry up. So just count. Okay, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, and obviously this is 9. Okay, and this is 10. Okay, so here we will get 10 different bands. Okay, because we have to count only those bands that have single copies. Like if I take 2 alpha, 2 alpha will show same band, na? That's why we are counting only 1 alpha, 1 epsilon, 1 theta. Okay, but whatever subunit is present in single, like chi, psi, okay, we have to calculate that. Okay, next. So I hope you all know this is the Ramachandran plot, and here through Ramachandran plot we can understand that which type of which conformation of a polypeptide chain is possible, like which conformation is going to form alpha helix, which conformation is going to form beta peptide sheet, this kind of thing. Okay, so here we put phi this side and we put psi this side. Okay, I hope you know the phi and psi. Like if you take this kind of things, like then like if you take the polypeptide bond, okay, there is something is NC alpha bond, and there is NC alpha, and what, this is CO, and again N H, and again C, this is C alpha, another C alpha carbon. Okay, so thus you will get another C0. Okay, and so this is the phi bond NC alpha. This is basically the phi, and this is basically the psi, like uh, C alpha C. This is basically the psi. Okay, and this is the omega. Okay, this is the omega subunit. So my question to you, hi Priti, my question to you is that I have indicated a red portion. Okay, I have indicated a red portion here. So you have to tell me the indicated are represented by a rectangular, okay, outline should not be. Okay, I hope you all know the Ramachandran plot. Now quickly tell me this indicated area is not possible for which? For anti-parallel and parallel beta-plated sheet, parallel beta-plated sheet, collagen, and right-handed alpha helix. Okay, quickly tell me. I hope you all know that this is a Ramachandran plot. It has 4 quadrant. This is first quadrant, this is second quadrant, this is third, and this is fourth. Now quickly tell me that which is not possible. Okay, so the answer will be right-handed alpha helix, because right-handed alpha helix just is it's here. Okay, it is a right-handed alpha helix. The denoted area is not right-handed alpha helix. It may be anti-parallel, it may be parallel, or it may be collagen. Okay, so the answer will be D, right-handed alpha helix. Now write down the phi and psi value for collagen. Anyone can remember the phi and psi value for collagen? If you can, then it's fine. Okay, otherwise I will tell you. No, it's D. Okay, Dipsika, it's D, right-handed alpha helix, because collagen is also there. Okay, I will tell you when I will tell you the value, you can understand. Okay, don't worry. So the phi and psi value is basically phi is minus 51 degree and psi value is basically plus 153 degree. Okay, so just tell me, if I take this as, if I take this point as 0, 0, then what will be there? Like phi minus and psi plus. Okay, so collagen should be there na. I think you can see the black point. Collagen should be there. Okay, collagen should be there. This position is collagen. Okay, so collagen is also here, and it is anti-parallel beta-plated sheet. Okay, and this is anti-parallel, this is parallel, and this is collagen. Okay, so don't worry. And right-handed alpha helix, it is here. Okay, and this is for left-handed alpha helix. Okay, so my next question is about hemoglobin. So I am requesting you to just look very carefully to the hemoglobin structure. Then I will ask you some question, and it's really very easy. If you understand the structure of hemoglobin properly, then you can obviously answer the question. Okay, so don't worry guys. Quick, so my first question to you, how many pyrrole rings are present in adult hemoglobin? How many pyrrole rings are present in adult hemoglobin? Quick, whoever is present here, like I don't know, over here. So Preeti, Neha, Dipshika, please try it. Okay, Abhishekta, I don't know you are here or not, so try it. How many pyrrole rings are present in adult hemoglobin? Okay, so we all know that this is alpha chain, beta chain, and in at each chain there is something heme. You can see that in the figure. Okay, it is heme, it is heme, it is Fe2 plus. Can you please quickly pyrrole rings are there in adult hemoglobin? Okay, so try to answer it properly. As we know, there are 4 chains, so at each chain we know that one Fe2 plus is bound. Okay, one Fe2 plus is bound at this sorry, like this. Okay, okay, these are the pyrrole ring, and this one is N for one histidine, and here oxygen bind. Okay, thus, so there are 4. No, there is, the answer is 4. Pyrrole ring is 4. spiral ring is 4. If you see the structure, the whole thing is making a ring. Okay, the whole thing is making a ring, that's why it will be 4. Okay, now my second question is, in the case of blue baby syndrome, the valency of iron should be. We know that blue baby syndrome is a disease where the infants or kids just suffering from the blue leaves. Okay, their leaves become blue. Okay, so this is the blue baby syndrome. So it's basically due to the nitrate. Whatever the farmers applied in the field, the fertilizers are just converted into nitrate, and then it just leached and reached to the groundwater, and when you consume it, it's really problematic for our kids. Can you please quickly tell me, in this blue baby syndrome, valency of iron, what is mean by valency of iron? Here quickly tell me that what is the valency of iron. It is 2 plus na, Ab 2 plus. So like this, I want to know this, as this is Ap2 plus, so at blue baby syndrome, what will be the valency of the iron? Okay, the valency will be 3. I am mentioning you, it will be 3. Don't worry. Next, how many 2,3-BPG, okay, can bind to hemoglobin when we climb mountain? I hope you all know that when we climb mountain, okay, we produce BPG, and that just reduces our affinity or oxygen binding affinity. So can you please quickly tell me that how many 2,3-BPG can bind to hemoglobin when we climb mountain? Okay, so the answer will be 1, because BPG bind only in the central. Okay, BPG bind only in the central, but the oxygen bind to each and every subunit. So oxygen bind to every subunit, but this is the oxygen, but BPG, it is the BPG. Okay, BPG bound to only one, like it's in central cavity, and it's in number 1. Okay, chalo, let's come to another question. Okay, so guys, I am giving you 30 seconds to observe the plasma membrane carefully, then we will ask you some question. Okay, we'll discuss some question. It will be very easy. If you observe it carefully, then you can answer. Yeah, so I hope you all know that this is the double membrane, double layer, sorry, not double membrane, this is double layer, and this is the like hydrophilic region, this is the hydrophobic region, this is the membrane bound protein, this is integral protein, this is peripheral protein, and there are some GPI linked protein, there is some membrane glycolipid, glycoprotein, all these things are there. Okay, so please just, okay, now my question to you is, which phospholipid is most abundant in the plasma membrane of the cell? Which phospholipid is most abundant in the plasma membrane of the cell? This PC is phosphatidylcholine, this SM is sphingomyelin, this PS is phosphatidylserine, and this PE is phosphatidylethanolamine. Okay, which phospholipid is most abundant in the plasma membrane of cell? PC, SM, PS, and PE. Okay, I hope you all know that lipids are asymmetric in nature. Okay, in the outer layer some lipid present in more amount. Okay, and in inner layer some lipid present in more amount. So the answer will be PC. Okay, phosphatidylcholine. Yes, it's phosphatidylcholine. It's the most abundant. Yes, fantastic, Neha. Next, move to the second question. Okay, yes, hi Akansa. Yes. So, which of the following is not true for lipid raft? I hope you all are aware of lipid raft. Okay, it's dynamic, it's detergent resistant, and cholesterol concentration is less here, and it helps in cell signaling. I am waiting for you guys to answer this question. Okay, yes. So my question is, we all know that lipid raft. Okay, we all know that lipid raft is something. Okay, so what is not true about lipid raft? It's dynamic, it's detergent resistant. Okay, and cholesterol concentration is less here, and it helps in cell signaling. Uh, Sorry, Naitik, I can't understand your queries or whatever you stated. Okay, I am also learning, so I can't make books. Okay, okay, okay. So we will arrange a session, but the thing is that you people have to attend the session. That's why I. Okay. So everyone is answering it's C. Okay, cholesterol concentration is less here. Obviously, it is C. Okay, everyone got it? Okay. I hope the question is there's no more question, but we will discuss the figure. Okay, I will ask you randomly question from the figure, and I hope many people are new here. I will request to all of you, please come in time so that we can discuss it properly in a structured way. So my first question, this is the, hope you can remember, this is the uh, action potential graph. Okay, here you can see that we started from minus 70, this is minus 70, this is minus 55, then it just go up to 30 plus, and then it come back again. So my question you to guys, okay, I'm just putting it 1, I am putting it 2, I am putting it 3, I am putting it 4. Which of the following, is due to voltage gated sodium channel? Which of the following is due to voltage gated sodium channel? I hope you all know the basic things about depolarization, repolarization. If you don't know, don't worry, I will tell you. Quickly tell me which one of the following, okay, is due to voltage gated sodium channel. Okay. I hope you know that there's one cell, and then something go out or something go in. You know the basic funda of depolarization, repolarization. Okay, if I take, okay, this kind of cells. Okay guys, quickly answer, don't waste your time. Okay, as well as mine obviously. Okay, I am expecting from the other people, Shreya and quick. Voltage gated sodium channel is related to, okay, like which is due to the opening of voltage gated sodium channel. Okay, which is due to opening of voltage gated sodium channel. I hope you know this fact that some kind of the, you know, resting membrane potential, this is the RF, resting membrane potential. Okay, a cell has to be always in resting membrane potential so that we can consider it as a shell. So the answer will be 1. Okay, because here what happened in a cell, the voltage gated sodium channel just open. So we know that outside in Na plus concentration is much more higher. That's why the Na plus just come inside. Okay, as Na plus come inside, it make the cell to quite positive. That's why, suppose imagine that initial in the inner portion there is minus and outside is plus. Okay, but as soon as Na plus go into the cell, what will happen, that the negative charge is will be quite neutralized. That's why the negative value is decreasing. It was at first minus 70, then it's reached up to minus 55, and then it reached up to plus 30. That means a cell is depolarized. Okay, a cell is depolarized. Okay, now my question is to you is that at which phase, at which stage, at which stage, okay, K plus leaky channel open, K plus leaky channel open, This is an MS key. You all know the funda of K plus leaky channel. Okay, so I am just explaining the graph. By the way, you answer the question, please. Okay, so what happened now? Sodium just go inside, go inside. Okay, after it, when it reach plus 30, what happened? Voltage gated sodium channel should be inactivated. Okay, should be inactivated, and simultaneously delayed voltage gated potassium channel should be opened, and it should be closed later on. Okay, and the delayed voltage gated potassium channel, what will happen? It will just remove the potassium inside to outside of the cell. Okay, then what happen, as positive charge is again getting outside, then the potential will again down and down and down. At this stage it is so down, that means it approximately minus I think minus 90. Okay, then it has to reach the resting membrane potential. That's why what happened, it the delayed voltage gated 3 4, everywhere delayed voltage gated potassium channel uh, is open. It is the answer. This is 1 2 3 4. Okay, I hope you people are not maybe people are bored or not interested. So should we stop now or should we stop here? I have a lot of questions to discuss, but I don't think so that you people have energy. Hi Pankaj. So I think we should stop now. Okay, so next Sunday we will discuss some more question if you have interest, then otherwise we should stop here. Okay, and if you have any queries, please just let me know. No, Samrat, I can't see people have energy. This is really, yeah, actually people, I think people are less energetic, so they should consume more energy. Okay, people, so here I'm ending the session, and thank you all. Otherwise, we have to stop here. Okay, bye bye. Take care. All the best.